Welcome to the Jumpman tutorial series. Based on the beloved classic arcade game Pac-Man, this project was created to be an easy-to-follow step-by-step guide that would give you the tools, techniques, and experience of creating a full game from start to finish. We have made all the original assets that we created for the game completely free. Links in the description below. For this project, if you wish to follow along step by step, you will need to first download the Jumpman project files, both of which can be downloaded in the downloads area of the tutorial site or from links in the description.
In this Bolt video, we'll continue developing our Ghost AI by varying each ghost's behavior, as well as implementing the ability for the player to instantly move from one side of the map to the next by entering the alleys in the middle of the maze. To begin, let's open our level 01 scene. With our scene now open, let's start by implementing the ability for the player to move from one side of the map to the next. First, let's go to our macro manager, and under our scene manager, let's create a new state, and we're going to call this new state player warp. And let's go into our new player warp state, and before we begin, let's go over the functionality that we need to implement within the state. So for our player warp state, what we want to happen is when the player enters one side of our alleyways, we want the player to be then transported to the other side of the alleyway. So to do this, we first need to create two triggers, and we need to put one on both sides of our alleyway. So let's create two 3D game object cubes, and we'll name the first warp trigger 1, and we'll name the second warp trigger 2. And we'll place one of each on both sides of our alleyway. And we'll need to scale our two new game objects to make sure that both their width and the height are the appropriate size for our alleyway. We need to also turn off our mesh render, as well as check the is trigger checkbox in our box collider. Next, let's create two game object type variables, and we'll call the first warp trigger 01, and we're going to call the second one warp trigger 02, and we're going to place each trigger in the appropriate value. So let's start our logic by creating an onTrigger enter node. And for the target, we want to get the component from our warp trigger 01 object variable. Next, we want to create a compare tag node. And for the tag that we wanted to compare, we want to get our player tag scene variable. From there, we want to use a branch node, and we want to say if that is true, we want that then to go to a transform set position node. For the value of the transform set position, we want to get the transform position from our warp trigger 02 game object variable. And for our target, let's create a new scene game object variable, and we're going to name that variable player active. And then let's temporarily move our Jumpman character into the value of that variable. Next, let's drag that variable into our graph, and let's get our transform component from our player active variable, and we're going to plug that into the target of our transform set position. With the basics of our player warp state complete, let's test out the functionality. We first need to toggle our player warp to start, and let's disable our ghost to make it easy for us to test. So we can now see entering a warp zone will instantly take the player to the other side of the map. So let's now go back into our graph duplicate all our nodes, and for our new node, we'll simply change our first variable to warp zone 2, and we'll change our last variable connected to the set transform position to warp trigger 1. With that complete, if we test our game at this point, the player will constantly be stuck, bouncing from one warp trigger to the next. So in order to avoid that, we'll need an add vector 3 node, which will increase 1 unit on our X for our warp trigger 01. And we'll subtract 1 unit on our X for our warp trigger 02, in order to place the player outside of the trigger the moment they warp to the other side. With that complete, let's test our functionality. Let's now move on to creating variants in our ghost enemies. Before we begin altering our ghost AI, in our game design video, The Value of Systemic Game Design, we broke down the specific movement patterns of each ghost.
Enemy ghost AI and behavior. All 4 ghosts act in similar but distinct ways. The red ghost is the most aggressive and targets Pac-Man directly. The pink ghost tries to get in front of Pac-Man. The light blue ghost tries to get in the space between the red and pink ghost. The orange ghost will follow Pac-Man to get close, then move away. This distinct behavior difference allows it to appear as though the ghosts are working together.
With that said, let's go into the state machine of the current ghost that we have on screen. In our state machine, we'll go to our ghost super state, and under our movement state, we'll go into our chase state. So in order to achieve the different behaviors of the ghosts, we simply need to create and add a add vector 3 node and plug that after our get position and plug that into our set nav mesh destination. Since we're currently setting the behavior for our red ghost, and our red ghost is the most aggressive and targets the player directly, we can essentially leave the target unmodified. However, let's create 3 vector 3 object variables, 1 for each ghost, so we can easily modify their behavior in the inspector. Let's also change our player object variable into our new player scene variable, since we'll be able to use that scene variable later on for our character spawning mechanic. And let's also change that player object variable into our player scene variable in our scared state as well. Next, let's duplicate our ghost red super state, and we're going to call the new state ghost blue super state. And we'll make a transition from our picker to our ghost blue super state. And inside our transition, let's copy our transition from our ghost red. And we want to change our object variable to isBlueGhost. And inside of our blue ghost super state, let's change our material generator to our blue ghost variables, textures, and material. And let's also change our blue ghost variables in both our blend shape states and our movement states. Next, let's duplicate our red ghost, change the name of our game object to blue ghost, as well as uncheck the isRedGhost variable, and we're going to check the blue ghost variable, and we're going to also save that into a prefab. And also let's move our blue ghost so it's not right on top of our red ghost. And in our blue ghost prefab, we're going to reset those transforms. With that complete, before we change our ghost behavior, let's first test out our scene and make sure that everything is functioning correctly. So we can see currently that we have both our blue and our red ghost variants, and all of our states seem to be working correctly. However, the ghost behaviors seem to be exactly the same, with the blue ghost always following behind the red ghost, or vice versa depending on their location. So let's go and adjust our blue ghost behavior vector 3. So the traditional behavior for the blue ghost, it tries to get in between the space of the red and the pink ghost. And since the traditional behavior for the pink ghost is to always try to get in front of our character, we want the values for our blue ghost to be slightly less than our pink ghost, but greater than our red ghost. So to do that, we're going to place a value of 2 in our X, and we're going to place a value of 1 in our Z. Lastly, let's adjust the Nav Mesh settings for both our blue and our red ghost. First, we'll take the height from 1.5 to 1. And we'll also decrease the radius for obstacle avoidance from 0.3 to 0.25. Next, we'll adjust the obstacle avoidance of our red ghost. We're going to change that from 50 to 25. We'll also change the acceleration for our red ghost from 8 to 12. So we can now see that our ghosts move somewhat similar but very distinctly from each other. They will take different paths and different ways to get to the character. And as we put the rest of our ghosts in, we can continue to tweak and adjust our numbers so that the ghosts seem to work more in tandem with one another. So with the base of our ghost behavior created, in our next video, we'll create the spawning system for both our player and our enemy ghosts. So join us in our next video.
Don't forget to subscribe and hit that notification bell to be the first to see this and many other tutorials, game development tips, interviews, and free game asset giveaways.